Hello everyone, welcome to Site Programming channel. Let me introduce myself. My name is Leela Madhuri. I am from 3rd BTech IT. In this video, I am going to tell about conversion from NFA to DFA. In order to know about conversion from NFA to DFA, we need to know about what is DFA and what is NFA. Firstly, what is DFA? DFA refers to deterministic finite automata. In DFA, there is only one path for specific input from the current state to the next state. DFA can contain multiple final states. It is used in lexical analysis in compiler. DFA does not accept the null move. That is, the DFA cannot change state without any input character. Here is an example for DFA. That is, here there is a specific input for a specific path only. There is no specific input for multiple paths. Next, what is NFA? NFA stands for non-deterministic finite automata. The finite automata are called NFA when there exist many paths for specific input from the current state to the next state. Here an example for NFA. Here the input A is the specific input, but there are two paths from Q0. That is, if I gave input A to the Q0, it may go either for Q1 or Q2. This is nothing but NFA. Next, conversion from NFA to DFA. In order to convert NFA to DFA, we need to remember this point. Every NFA is not DFA, but each NFA can be translated into DFA. NFA is defined in the same way as DFA, but with the following two exceptions. It contains multiple next states and it contains epsilon transition. Here is the steps for converting NFA to DFA. That is step 1. Convert the given NFA to its equivalent transition table. Next, step 2. Create the DFA's start state. And next, step 3. Create the DFA's transition table. Step 4. Create the DFA's final states. And step 5. Simplify the DFA. In this step, we can simplify the DFA by removing unreachable states or remove dead states or merge equivalent states. And finally, step 6. Repeat steps 3 and 5 until no further simplification is possible. Here I am taking an example of NFA. I need to convert this NFA to DFA. In order to convert this NFA to DFA, initially I need to design a transition table for the given NFA. This here it is clearly describes that it is an NFA because if I give input A to Q0, it either go to Q0 or Q1, which means a specific input for multiple paths. So let's start our procedure. Here step 1, transition table for given NFA. I am designing the transition table for the given NFA. That is, here the states and A and B are the input symbols. If I gave input A to Q0, that is, if I gave input A to Q0, it may go to either Q0 or Q1. So I mentioned here Q0 or Q1. If I gave input B to Q0, that is, if I gave input B to if I gave input B to Q0 state, then it go to Q1. That's what I mentioned here. In the same way, I describe all the states in this NFA. Here, by using the transition table of NFA, which we discuss in previous. With that help of this transition table, now we can design the transition table for DFA by following some rules, which we mentioned in the previous steps. That is, start from the starting step, that is Q0. If I gave input A to the Q0, it may go to Q0 or Q1 in NFA, but in DFA it should be considered as a single state, that is Q0 and Q1 should be considered as a single state. If I gave input B to Q0, that is Q1, which I described here. Next, if I give input A to Q0 and Q1, here Q0 and Q1 is considered as a single state, but in the previous transition table there is no state which is Q0 and Q1. So we need to describe about the states where they going. We need to merge those two states here, Q1 and Q2. So apply union for Q0 and Q1 when giving input A, that is Q0, Q1 and Q2. If I give B, input to the Q0 and Q1 state, that is nothing but union of Q0 and Q1 when applying given input B, that is Q1. In the same way, I am calculated for the Q0, Q1 and Q2 node also. If I give input A to Q0, Q1 and Q2, that is a union of Q0, Q1, Q2 for input A, that is Q0, Q1, Q2. Next, if I give input B to Q0, Q1, Q2, that is union of Q0, Q1, Q2, that is Q1 and Q3, considered as a single state. Now I am describe about Q1 and Q2, Q1 and Q3 state. If I give input A to Q1 and Q3, nothing but the union of Q1 and Q3 when giving input A, that is Q2, which I mentioned here. If I give B input to the Q1 and Q3, that is the union of Q and 3 while giving input B, that is Q1 and Q2. Now I am describing about Q1 and Q2. If I give input A to Q1 and Q2, that is union of Q1 and Q2 when giving input A, that is Q2, what I mentioned here. Next, if I give input B to Q1 and Q2, if I give input Q1 B for Q1 and Q2, the union of Q1 and Q2 is the union of Q1 and Q3, nothing but Q1, Q3. In the same way, I am calculating and describing all the states. Now here we had an ambiguity. That is, for Q2, if I gave input A, if I gave input A Q2, it is a null, that is 5. But in NFA, but in DFA, there should not be any null. So I need to mention a dead state, that is Q4, which is a new state. So by placing these dead state in this here, there is no completion for DFA. In order, if I mention these state, I need to describe that state also. But for dead state, if I give any input, it remains itself only. That's why if I gave input A and B to Q4, it remains at Q4 only. This is the transition table for DFA. By using the transition table, we can easily design the transition diagram. So here is the transition diagram for DFA. First, starting from Q0 state. If I gave input A to Q0, it go to Q0 and Q1 state. If I gave input A to Q0, it goes to Q0 and Q1. If I gave input B to Q0, it goes to Q1. If I gave input B to Q0, it goes to Q1. In the same way, if I gave input A to Q0, Q1, it goes to Q0, Q1, Q2. That is, if I gave input A to Q0 and Q1, it goes to Q0, Q1 and Q2. If I gave input B to Q0, Q1, it goes to Q1. If I gave input B to Q0, Q1, it goes to Q1. If I gave input A to Q0, Q1, Q2, if I gave input A to Q0, Q1 and Q2, it goes itself Q0, Q1 and Q2. If I gave input B to Q0, Q1, Q2, it goes to Q1 and Q3. That is, if I gave input B to Q0, Q1, Q2, it goes to Q1 and Q3. If I gave input A to Q1, Q3, if I gave input A to Q1, Q3, it goes to Q2. If I gave input B to Q1, Q3, it goes to Q1, Q2. If I gave input B to Q1, Q3, it goes to Q1 and Q2. If I gave input A to Q1 and Q2, it goes to Q2. If I gave input A to Q1 and Q2, it goes to Q2. If I gave input B to Q1 and Q2, it goes to Q1 and Q3. If I gave input B to Q1 and Q2, it goes to Q1 and Q3. If I gave input A to Q1, it goes to Q2. If I gave input A to Q1, it goes to Q2. If I gave B input to Q1, it goes to Q1. If I gave input B to Q1, it goes to again Q1 only. In the same way, I design the remaining states also that in this transition diagram. Here, these encircled states are considered as the final states because in previous transition diagram, the final in previous transition table for NFA, Q2 and Q3 are the final states. So in this transition table for DFA, where Q2 and Q3 exist, those all states should be considered as the final states. I hope everyone should understand about how to convert NFA to DFA. Thanks for watching.